So this next session, we have our guest instructor, Ian Carroll. Ian is an associate research scientist with NASA at the University of Maryland, Baltimore County, working with NASA Goddard Space Flight Center. Ian supports science data production for NASA's space mission and also brings background in ecology, evolution, and marine biology. Ian is also a NASA Openscapes mentor, and he will be sharing today real-life stories from his work and experience. This session is going to be divided in two, like Ian's presentation, that it's going to be like 50 minutes, and then we are going to have a discussion about what we can learn from Ian's story. So, Ian, I will pass it over to you.
Okay, thanks, Ronnie. I'm going to try to share a tab. So I think that the Better Science for Future Us screen is showing for you. Yes, thank you, Andy. Okay. And also there is a link to the slides in the notes. You're welcome to toggle along. I don't think I have anything to click in there. So if you want to just sit back and follow me, that's fine as well. But if you prefer jumping in around at your own pace, you can do that later. Let me reset this. Okay, so Better Science for Future Us. I want to try to break that down a little bit. Funny. Okay, just realized some of my speaker notes are not here, but that's okay. I know what I'm going to say. The title of this talk, Better Science for Future Us, is kind of a series. We've had a lot of people do it, and there's recordings on the website from previous Better Science for Future Us guest instructors. So we all take a different approach to telling a Better Science for Future Us story. And what I want to do first is just break down what we mean when we're talking about better science and future us, reiterating some of the things that Julie said. But when we talk about better science, we really do mean it's science that we do believe open science practices get towards something that is a better product, partly because we think we spend less time and funding on reusable elements. I'm going to talk a lot about that feedback loop and getting that feedback loop spinning between tools and people is what we think that a lot of open science does to actually help make better science. One of the ways that happens is that we move from this idea of just enabling reproducibility. Being able to reproduce something is kind of a core part of the scientific method. That's a low bar. You got to get there. We want to really move that from not just enabling reproducibility, but being more active in facilitating reproduction. We want to really facilitate people's ability to take those reusable elements from projects and fork them, copy, modify them for other projects that they're working on. Future us, yes, us definitely includes your future self that Julie mentioned, and it definitely includes what I've found working in the Openscapes community is it includes a more inclusive, a more engaged, and just more collaborators. We all love the experience of having a real successful collaboration where you really feel like you've worked together with somebody new in a deeper way than you've ever done before, and that's part of what Future Us is about. And just a reminder also that we're talking about little things that you can do day to day. So there's no reason to delay trying to adopt some new practices because tomorrow counts. Tomorrow counts as the future. No reason to not start trying things. The pathways, the paths. I want to use this hiking analogy, metaphor, to talk about the feedback loop a little bit more. There's two parts of the feedback loop. And I'm going to use the analogy of this group getting started here at the trailhead, which maybe this is where some of us are, but this little lime green team down here is what I'll call the trail users, to build on the analogy. And what we Openscapes champions get to do is practice the open mindset equivalence of the leave no trace principles of trail use. So Julie Julie put some of those principles in her open mindset talk, and I'll rather than reiterate them here, I'll get back to them in a. I'll mention some of them again in a minute, but let's just in this analogy, there's kind of these principles that we're going to adopt at the trailhead, analogous to leave no trace principles when you're going out to enjoy the wilderness. That's one aspect. We have this other team up here hidden in the figure, the trail crew, hard at work, and it's the idea of trail maintenance. So this is the sense that making sure that this landscape is welcoming takes work, and open science, being part of open science, is also involves doing the work for trail maintenance. And there's alternative ways to participate. So what I want to do is tell you a little bit about my story for thinking about how did I get to be a contributor, and what is contributing to open science look like to complete the lower half of that feedback loop, because we really get that feedback loop spinning when people are doing some of both, when people are out there using the trails in the wilderness, but also finding some way to be a contributor to the trails in the system. So that's my goal. And I guess I'd say my other goal is to make you absolutely sick and tired of this hiking trail metaphor. Sorry, we're just gonna keep doing it. Okay, so maintainers, this busy beaver. I want to talk about that guy, and I want to talk about that guy being me. I'm an ecologist and a data scientist supporting the PACE mission. That's the Plankton, Aerosol, Cloud, and Ocean Ecosystem mission, and the users of the ocean biology DAX data that OBDAC distributes PACE mission, as well as several other data sets. And the OBDAC actually also distributes some suborbital data. It's where the sea bass team sits as well. For my science, I'm researching estimates of phytoplankton diversity and cloud obscuration with the PACE Ocean Color instrument using supervised machine learning. So very disparate topics, but I'm the data scientist, not the domain specialist. So that's why I can be doing both phytoplankton diversity and clouds in the atmosphere. I don't know a whole lot of details about the domains, but I come at it from the data science perspective. Formally, just give you the little rundown of, sort of like where I've been, what I've been up to, which one moves, this one moves. Formally, well, I was not doing anything before coming to NASA. I had a little science break during COVID, did some home projects, which was fantastic. But before that, I've meandered a little bit. I was at a private sector company for a while doing data science for development agencies. I was at the National Socio-Environmental Synthesis Center doing data science to support environmental synthesis projects at that NSF-sponsored center. Postdocs at Georgetown, Woods Hole Oceanographic Institution, advanced degree at UC Santa Barbara. I had my first real job at a think tank in Washington, D.C. I had my best job being a field technician for the U.S. Forest Service. Did my graduate work in Rhode Island at Brown. My undergraduate work in Rhode Island at Brown. But it's a little bit of a meandering trail. So I've had a lot of experiences encountering open science in different ways through each of those different places that I've occupied. So the feedback loop has, the use end on the upper side, and we all want to practice some of the open mindset, open science principles that Julie set out, like sharing early, good enough in iteration, getting our things out there so that we have the opportunity to get feedback early, and also to share reusable elements early. Know that we're going to iterate on them in the future, know that we want to get them out there so that maybe other people can iterate on them, being willing to accept other people's help when they're iterating on ideas that you've put out there, and also being bold and confident in iterating on things that other people have done and saying like, yeah, I can take that and I can maybe do another round of improvement on it. Onboarding is really important, always, helping people understand what tools and practices you're using to improve your science. Documenting how you're using them is one way of onboarding people. And I don't think we're going to practice it during this champion session, but we also talk a lot about co-working, seaside chats as kind of a particular way of getting together and doing some sharing about the projects that you're working on. And these are all ways that we as people are going to be, using the tools and practices and during that upper half of the feedback loop. For myself, I try to do that in the science projects that I'm working on. One thing that I spend time on is munging IFCB buoy data, the imaging flow cytobot, an in situ data platform for collecting phytoplankton community composition. And I'm interested in matching it up with observations from the Ocean Color Instrument, from the PACE mission. But this in situ data is a lot different. It's a lot hairier than our remote sensing data that comes in nice boxes. So it takes quite a bit of work. But I try to use all of the open science tools that I can along the way. Did you know that Earth Access can provide you access to CBAS, which is one place where IFCB data is. So I want to sort of like demo that and help take advantage of it. I use things like spatiotemporal asset catalogs, sort of a community maintained standard for how you can catalog these kinds of data. So that's using. But I'm also been thinking about how I can be a contributor while working on this project. And one of the ways is I've started work on a Python package that I'm calling X-Array CBAS, and it's a backend for opening up CBAS data sets as an X-Array data frame. It was something, I was writing code to, be reading CBAS data, which is a type of format that we use in the CBAS data archive for ship data mostly, ship and buoy data mostly. And was working with reading it into Python, said, hey, why don't I package this up, see if I can make it professional. It's as a fun project. So that's kind of, an example of that bottom half of it when we're contributing. But, writing a Python package is like, originating a Python package and doing it is a lot. That's not something you're going to do every time you're thinking about how do I contribute back to make this feedback loop really spin. And I wanted to lay out, in my history, what a couple, early examples of contributing look like. They do all involve GitHub. It seems to be a theme for today, and it's going to be a theme continuing on. Doesn't have to be GitHub. You can communicate these ways and work on these projects using other platforms as well, using GitLab or Bitbucket or whatever else. But yes, GitHub is definitely sort of like the natural home for a lot of these open science projects. And I want to break it down into 3 levels. So back using the trail metaphor that I'm going to make you sick of, I said that there's 3 levels of kind of doing trail maintenance or being a contributor. And I think level 1 is kind of analogous to that visitor use survey that you might encounter at the trailhead. And an example of how you would do that is just giving feedback. And when we're doing that for open science tooling, a lot of it is just taking the time to raise an issue about some rough spot that you encountered while you're working with some open science tool. And so I dug back into my GitHub history, and this is the first issue that I raised on a Python package called PyMySQL. It enables you to use MySQL databases in Python, and I was having trouble a long time ago. And so this is the first time I contributed to an open source project in this way. And you can see I wrote like 3 sentences. I didn't give a code example. I didn't post any versions of anything. I did all sorts of things wrong in terms of like how you would consider making this like a good issue on GitHub. But it doesn't matter. You get feedback when you start doing it. By the 3rd issue I raised, I probably was doing it in a much more useful and informative way. But even just this simple thing of pointing out a problem that I encountered, led to some engagement, and it really helps a maintainer understand that their project is really getting taken up. Minute 12. I think I'm still doing okay. Level 2 is contributing code. So this is the analogy, the metaphor is being on trail crew. Maybe actually doing some coding or helping with some documentation, working on a project that you don't really have ownership over, but you're gonna put an hour or a week, whatever it is, into doing the work that actually improves the tooling. For me, the first time, I know I haven't done many of these, but when made a pull request to the X-Array package, I was like, wow, I'm not a software developer, but they're going to accept the pull request from me. And it was a great experience. It wasn't much, but it was an improvement that I think, a couple other people commented in the thread. People have no idea who they are, but they were like, yep, I've encountered this issue too. Looking forward to getting this fixed. And we got it fixed. So, those little wins really make you feel like you're a part of the community and really help everybody else along the way. Finally, the next level is really getting to know the ins and outs of a package. And the designation maintainer, I've been saying trail maintenance, but the designation maintainer kind of carries a special significance in open source software. It really means that, you've taken the time to study how that software works and think about what its future directions are. And I really think it's a mark of success. It's a hallmark of success in the open science community when the originators start welcoming maintainers into a package and are able to welcome new maintainers into a package that didn't have anything to do with originating it. So I had nothing to do with originating the Earth Access package, which I think probably you may have heard about it. It helps us get access to data that's in the Earth Data Cloud. It had nothing to do with originating it, but I've been welcomed in now to be a maintainer on the package, and I think it really indicates a community that's functioning well when they welcome in maintainers to be involved, even though they might have come from a totally different history, and when there are people out there that weren't involved but really want to adopt a trail. They say, I really want to be involved and get to know everything about this package in a way that I can really sort of like help steer it and help support other work that's being done to improve it. So those I'm calling sort of like the 3 levels that I see for sort of thinking about closing the feedback loop. But I want to open our discussion about this idea of doing better science for future us by putting out, hypothesizing a goal that I think about a lot and a question that I think about a lot, and see what you guys think about these two things as well. And this goal is, apologies to Julie and apologies for Allison Hurst for modifying their wonderful artwork and their feedback loop design here. But I want to apply our open science practices beyond tooling. I think a lot of us think of tooling as software platforms, and when we're trying to do open science, I want to extend these same practices to creating artifacts, so that we create models and we create data sets in the same way, in a very open way, in a collaborative way, and a reusable way, so that it becomes easier for all of us to comment on, collaborate on, work iteratively on each other's models and each other's data sets. So that's like my goal for thinking about how to take open science further and all these practices further. And then my question is, what is it that sometimes makes contributor work feel like service rather than part of the job, rather than what we do, what we get up in the morning and come to work to do? I have some thoughts on why it feels a little bit more like service than part of the job, but I would be interested in your thoughts as well. And I will leave it there.